buckle up because we're going to do some specific heat calculations. In this first example, it says how much heat must be released to decrease the temperature of 10 grams of aluminum by 33 degrees Celsius if the specific heat is 0.90 joules over grams degrees Celsius. Okay, well, let's see. What do we know? Well, we know that energy is being released, and we know that we have 10 grams of aluminum. The temperature is being decreased by 33 degrees, and we have a value of 0.90 for specific heat. So it's asking how much heat must be released. So we know that we're trying to find our Q value here. We know our mass is going to be 10 grams. It's coming from the question. Now, our change in temperature, we don't have a final and an initial. We know that the temperature is being decreased by 33 degrees. So our delta T is going to be negative 33 degrees. It's being decreased by 33 degrees. And then finally, we know that our C value is 0.90 joules over grams degrees Celsius. Okay, so our equation is Q equals MC delta T. Oh, look, it's actually conveniently right there as well. Well, let's plug in what we know. So we're trying to find Q. Our mass is 10 grams. Our C value, our specific heat, is 0.90 joules over grams degrees Celsius. And our delta T is minus 33 degrees Celsius. So we pull out our calculator and punch this in, and we get a value of negative 297 joules. Now, if you notice, we have a negative value, and that means that it's exothermic. So we have a negative Q value. It's going to release energy. All right, let's look at another example here. So we're working with gold this time. Now, if this doesn't get you excited, I don't know what will. So we've got gold as a specific heat of 0.129 joules over grams degrees Celsius. It's asking for joules. So again, we're going to be finding our Q value. And we want to raise the temperature by 63 degrees, and it's a 15 gram sample. So we've got, let's see, a specific heat value of 0.129 joules over grams degrees Celsius. Our mass is 15 grams, and our delta T value, so our temperature is being raised by 63 degrees Celsius. And again, we're going to plug into our formula, Q equals MC delta T. So our mass is 15 grams. Our C value is 0.129 joules over grams degrees Celsius, and our change in temperature is 63 degrees Celsius. So we push this in our calculator and we get an answer of 121.9 joules. All right, we have a mystery substance this time. So we have an unknown substance with a mass of 100 grams. It absorbs 1,000 joules while undergoing a temperature increase of 15 degrees. This time we're finding the specific heat value. So we have a mass of 100 grams. Our Q value this time is 1,000 joules. It's going to be a positive number because it's absorbing energy. It's going to be endothermic. And then our change in temperature is going to be 15 degrees Celsius. The temperature is being increased, so our delta T value will be positive. So we have our formula, Q equals MC delta T. So we plug in what we know. We have 1,000 joules. Our mass is 100 grams. Our temperature is 15 degrees Celsius. And then, of course, we have our specific heat. So to get C by itself, we're going to rearrange our equation. We're going to move our our 100 and our 15 to the other side. So our equation is going to look like this. We'll have 1,000 joules over 100 grams times 15 degrees Celsius. And when we put this in our calculator, we get an answer of 0.67 joules over grams degrees Celsius. So one of the cool things we can do with this information, we could go look up on a table of specific heat values, and we could identify what this magic unknown substance is simply by looking up its specific heat value, and that would help us identify it. It's kind of foreshadowing what we're going to be doing in our lab coming up here. All right, good old graphite has a specific heat value of 0.709 joules over grams degrees Celsius. If a 25-gram piece of graphite is cooled from 35 degrees to 18 degrees, how much energy was lost by the graphite? So we're looking for energy, so that's going to be our Q value. So our C is 0.709 joules over grams degrees Celsius. Our mass here is 25 grams. And delta T, final minus initial. So let's see here. To find this, we're going to do our 18 minus 35. So this is our final. And when we do that, we get an answer of 17 degrees negative, of course. And let's plug in. Okay, so our mass is 25 grams. Our specific heat value, 0.709 joules over grams degrees Celsius. And then finally, our temperature, negative 17 degrees Celsius. So when we put this in our calculator, we get an answer of negative 301 joules. And remember that negative right here, this means exothermic. So when we have a negative Q value, that just simply means that we're releasing energy. All right, in our final example, it says liquid water has a specific heat of 4.18 joules over grams degrees Celsius. Water released negative 9,750 joules of energy and undergoes a temperature change from 65.5 to 58.5 degrees Celsius. What's the mass of the water? Okay, so let's see what we've got. So our specific heat value is 4.18 joules over grams degrees Celsius. We also have our Q value, negative 9750 joules. And then our delta T, change in temperature, final minus initial, 58.5 minus 65.5. So when we do that, we get an answer of negative 7 degrees Celsius. And let's plug in. Q equals MC delta T. Our Q value is negative 9750 joules. We don't know our mass. Our specific heat value is 4.18 joules over grams degrees Celsius. And then our temperature change of negative 7 degrees Celsius. So we want to get mass by itself. So to do that, we are going to divide both sides by 4.18 times negative 7. So we'll have mass is equal to negative 9750 over 4.18 times negative 7. So of course the negatives here will cancel out when we put this in our calculator, and we will end up with an answer of 333 grams, and that'll be our mass. So using the information from these questions, of course, we can go through and we can find any of the values. We can find our energy, which is Q, our specific heat, which is C, our change in temperature, or the mass.